Welcome to a new test and teardown video. This time it's a new Rohde Schwarz equipment. This one is a panoramic adapter type ESUP. It's actually quite big. It's from 1967. It was quite easy to find a manual online with pictures and explain about exactly what it's doing. So I will put in some pictures here so you can see how they presented this unit. It is of course a spectrum analyzer for IF signals for a radio. So that means it takes the IF that you're receiving and displays a spectrum on this little CRT. Two versions exist, 10.7 megahertz or 21.4 megahertz, and this one is 21.4. And this is very very nice and smart with this IF spectrum view, so you can handle disturbances from nearby channels or other radio stations that is like too close to the material you want to receive, and this is causing disturbance. And this way you can fix it by looking at the IF and adjusting your receiver's filters, bandwidth and center and all that kind of stuff. And this is exactly what all radio amateur receivers got today. A spectrum view of more or less the kind of bandwidth you want to receive. So it's very very effective, definitely. It is 12.6 kilograms, so it's actually quite heavy. And there's only those two connectors here at the front. This is a little funny one, and this is actually even more funny. What does it say? I can read some text down there, by the way. I don't have the pin out for that one. I could, of course, go and find the schematics and stuff like that. Probably I could do that. Sometimes you can find schematics on Rohde Schwarz equipment. But I think it's more fun to open it. And I can also hear we got some loose parts in here. So I don't expect to be able to power this up. At least not the first day, but something. I need to do something before I can power it up. Yeah, look at the size. And then we got no connectors and nothing on the back. All we got is here in the front. So there's supposed to be a lid that's completely watertight here, and then you lock it in here. So it's almost like it's for military use or something like that, right? It's looking quite pro kind of use, right? So this is the first view inside, and this is the bottom. The first thing I see is a loose wire. And there was also a loose screw inside the case. But this one is not. No, it is not. I thought that one was the... Oh, there's another one down here. So there's a wire. Oh, let me get some light. So there's a hole here, so there's a connection for the CRT that fell off. And then there's another one up here, that's probably the anode. Oh, that is nice. Look at the... Oh, I love the way this is coupled. Yeah, power supply here is nice and clean. I also really like the text on all the different boxes, so you know where you're going. That is great. I was hoping to be able to trace down the connections from this connector, and I can see three big thick ones, and they probably go to the... That gotta be the on-off switch, right? So I can probably see... Aha! Here is... Why are we doing that? So this one is coupled for 220, right? But we also got some other decisions to make here, 12 or 24. That's interesting. Oh, that's some really cute diodes. So yeah, this is the top view. And a lot more power supply components. A lot of diodes and whatnot here. And it looks like you can unplug that. More connectors. See the connector for the CRT is disconnected. And that is loose as well. So somebody tried to do some service on this unit, so I don't expect it to be working. Ah, a ground wire that goes to the chassis is connected directly to the side of the CRT. That is interesting. So when I rotate this unit, I also hear a loose screw inside, and I think it is inside that box. So now I think I'm not able to solve this in a quick and dirty way. Oh, we got some more connectors. Yeah, again, super loose. Are they really supposed to be that loose? Oh, they were half the way out. That can't. Oh, they are so loose, they just fall out. Is this really? This is not the kind of Rohde Schwarz quality that I'm used to. That is a very bad connector type here. I need to look at that. I'm still searching for my loose screw in here, and I still haven't found it. So the left side, the top left unit here, that gotta be the markers and the sweep oscillator, because you got the crystal and all that kind of stuff here. So, and probably some filters as well, right? And that will be the deflection amplifiers. It's quite easy to see all those power transistors and trimmers and stuff like that. And the text on the top here also explain, see, X amplitude and X and Y and stuff like that. So it's also got some stuff for the CRT. So this is the bottom left. That'll be the filters for the 1 and 3 kilohertz node, 3 and 10 kilohertz bandwidth amplifiers. And that one will be the discriminator and symmetry, whatever that is. That's a little bit interesting. Hope that works. Oh, that is a fun way to access that potentiometer. And I think I found the missing, the loose screw. Here we go. Because I saw that one. So here's the screw and here's the little washer down there. So then I dare to power it up. Oh yeah, about powering it up. All those connectors, they are so loose, and they're just supposed to be like that. We also got some connectors here at the back, exactly the same type, and they're completely unsupported, and they just nearly fall out by the slightest little touch. I mean, this can't be as they are supposed to be. Maybe this plastic just was getting old. I don't know. It's just the weirdest choice, really. I've not seen this kind of bad decision in component choice in Rohde Schwarz equipment in a long time. I mean, they are really famous for doing good stuff, so this confuses me a little bit. That was a little bit annoying. It turns out this main on-off switch consists of 3 sections, And the red wire, I have no idea what that is doing and where it's going. That is weird, isn't it? So 3 signals and 3 thick wires from this funky power entry connector. Yeah, goes to this switch, but I actually believe it's an auto fuse as well, 10 amp auto fuse. Really? But I've tried to measure those, and they kind of go to, there's a connectivity to the mains selector, and the other one is connected to a fuse on the other side. So my best guess is this is going to be mains voltage input, and the sensor pin is chassis, so this is protective earth. So that is what I will do. I'll just try this and carefully crank up the voltage and see if there's any anything going on here. So I think it's going to be more fun if we do this together. I just leave this in power on, and then I crank up my variable input here. Let's see if there's anything going on. I was hoping to see a little bit of light in that one, but this is only 67 volts and it's only using 2 watts. $140 volts, 160, 70, 80. Let's go for 228. And it's using 16 watts. We have a nice green light here. Let's see if there's anything going on the CRT. Yes, there is a tiny little sweep down there. Look at that. How do we move that one? Okay, so there's a position. Oh, and now it's sliding out of the. But there was definitely. Yeah, here we go. Oh man, lucky. So I think I found the problem, because this is called gain and not position, right? So when you move the gain on one, it's probably some DC. So there's a broken deflection transistor or something like that, because then you can get a bug like that. Other than that, nothing is actually responding to anything. I don't get any marker lines as far as I can see, so that is not working. I don't see any kind of results whatever I kind of touch. I think I figured out a lot more now. So this is actually called a level line, and you use this indication here to tell where is the level line. And if you turn on and off the level line, see, now it sweeps a little bit faster here because it's doing this more often. If you turn on your level line, you have that one, and then you can also move it using this knob. And of course, when you have your level line here, then your gain will also affect, see? More gain moves the level line up, and it moves ground down because there's some DC kind of, I guess, right? And still haven't figured out about the markers. Different bandwidth also gives different amplitude. I would kind of expect that. I try to input, at the moment I'm inputting 21.4 megahertz. And you see, on and off here, I don't see anything at all. What I could do is, it looks like somebody's been modifying a little bit in this unit. So maybe they changed the input filter, maybe they changed the first mixer oscillator. So maybe this is not 21.4 megahertz anymore. So it could have been modified. I tried to put in 10.7, and there's still no response. So exactly what is going on, well, I don't know yet. Let's look a little bit at the block diagram. In the upper left we see the input and an input attenuator, and that's of course so you can amplify the signal to the right level. And there's of course a bandpass filter, so that is 10.7 or 21.4. Then the next section, that will be an amplifier, and then there is a mixer, or there's actually also a modulator you can turn on and off, and that is our marker generators. As you can see here, they are also made in the 21.4 or 10.7 domain, so they go straight into the first stage. I mean, it's mixed together before the first mixer. So of course those markers, they must be in band, otherwise they're not going to be shown on the screen, right? So now we see here in the middle the oscillator system, and then we have a mixer and a 4.3 megahertz or 100 kilohertz wide filter. So this is an IF section, and then there is a detector that is just shown by a diode. So this diode detector is actually a mixer, and it is mixed with a 4.6 megahertz oscillator. And then we have two different filters where we select the bandwidth. This is actually a video bandwidth. This is what we call it. And then there is a logarithmic amplifier, and of course the Y deflection amplifier. And if we look to the bottom right, here is our X amplifier. This is also our sweep amplifier. And then there is this sweep oscillator. And let's look a little bit more inside the unit. So after we have been looking a little bit at the block diagram, I think it's a lot easier to see what is going on here in the deflection system. I've added a little bit of text here, and what they have done is they have added some really nice deflection transistors here for X. So all this is X. Let me hold it like this. Maybe that is better, right? So we got X position and X gain, and so here's actually a cascade coupling, and then we have a little pre-driver, and this via we have down here, that is actually X input. So I cut this so I can feed in my own signal. And what we see here is the sawtooth or the sweep oscillator. So it's actually done here on this PCB. The Y deflection, that's only those two transistors. One is just doing the position, and there is no other trimmers for Y in this on this board. So that transistor here goes straight to the input here. This is the Y input, and that is a black and white wire, and that goes directly to this potentiometer here on the front. And that one is where we select how much gain we want. So this is our Y input signal. And the fun thing is that the Y system here is running at a negative 20 volt offset. So that's just the analog level of the input. So here, if I poke around with this, I can change how much Y I want. And X is quite easy here. We got gain and position and all that kind of stuff. Other than that, there are so many problems with this unit. Oscillators not working, mixers not working, signals not coming in and out, and all those connectors, they're just falling apart by the slightest touch. So it's just impossible to make this unit work for its intended use. I'm sad about that, but it could have been fun to show you guys some spectrums of 21 megahertz and all that kind of stuff, because it is a really cool device for radio receivers, and sometimes I do get radio receivers in and could save this for later, but that's just super bad. I don't want to waste a million hours debugging every little tiny part in the different oscillator mixer sections. I'm sorry I don't have a million hours to do that, but that is the problem. And what also drives me a little bit nuts is that mains entry connector, and I can't find the schematics. So if any of you find some free schematics, please post links to schematics so that we can all enjoy this unit in the future. So other than that, I will just say thank you very much for watching, and please come back real soon.